Hello everyone, how are you? I hope you're having a good day, and in this video we're going to be looking at SI units and orders of magnitude. And this is one of the areas where maths and science really do meet, and so keep that in mind as we go forward. But when scientists are working, they need to be sure that they are working carefully and working in the same units, and the units that we use is what today's video is all about. So speaking of units, an ancient unit is the cubit. This unit was used in ancient Egypt about 5,000 years ago, and 1 cubit was the distance from the elbow to the tip of the fingers. So there we can see 1 cubit down a person's arm. So, like I say, the cubit was an ancient unit. Why do you think that people don't use the cubit today? Pause if you want to think about it, but the reason we don't use the cubit today is because cubits are not all of the same. So some people have short forearms and some people have long forearms, and that changes the unit. Actually, the Egyptians did have a unit called the royal cubit. That was the very first standardized unit of measurement, but overall we have better units today than the cubit. What we know about science today means that scientists need precise answers. They need to be very exact in their numbers. And so, over time, we have made better and better units. And the modern system of units that we use in science is the SI system of units. So, what are SI units? Well, they are a system of units that are used most of the world over. And the SI system is based on the metric system, which uses orders of the number 10. So, 10, 100, 1000, etc. The SI in the name stands for the French Système International d'Unités. I'm not sure how my pronunciation stacks up there, but the French designed the metric system and they also set up the SI system of units. So let's have a look at the units. There are 7 basic units in the SI system, and here they all are. There is the meter, which we use to measure distance, the kilogram, which we use to measure mass, the second for time, the ampere for electrical current, Kelvin for thermodynamic temperature, candela for luminous intensity, and the mole for the amount of a substance. And with those units, we can calculate just about everything that we need to understand the world. You can see that each unit has its own symbol, and often they are lowercase letters, but there are a few which are uppercase letters. Typically, a unit uses an uppercase letter if it is someone's name. There was a scientist called Ampere, and there was a scientist called Kelvin. So there are many other units that we use, but they can all be made up from these 7 basic units. For example, you might have heard of the Newton as a unit of force, but 1 Newton is also equal to 1 kilogram meter per squared second. And kilograms, meters, and seconds are all basic SI units. Whatever unit you are using though, you can make that number bigger or smaller with orders of magnitude, and that's what we're going on to look at next. So, orders of magnitude are ways of using very large and very small numbers. Sometimes in science we are dealing with millions, billions, trillions, or even larger numbers. The first way we have of doing this is to use named orders of magnitude. Quick question for you. What do we call 1/100th of a meter? Have a think. Pause if you need to, but in fact we call it a centimeter. Another question. What do we call 1/1000th of a meter? Now, if you look at the answer to the first one, the second one might be a bit easier, but 1/1000th of a meter is a millimeter. And so these prefixes, milli and centi, that we use are names for orders of magnitude. So here is a table of some of the most common orders of magnitude and the names that we give them. You can see that the ones near to 1, they are not used very much because they are such small numbers, although we do use centimeters. But then above that you can see kilo, like kilogram or kilometer. Gigabytes on your computer, although many of you are probably up to terabytes now. But you can see the order is given as a number, and this is the orders of 10 away from 1. 10 deca is 1 order away from 1, but mega, 1 million, is 6 orders away from 1, and that is just the number of times you multiply by 10. Same goes on below 0, and again, each of these different orders of magnitude has its own symbol, which might be either an uppercase or a lowercase letter. Let's just look at a couple of quick examples. If you have 1,000 grams in weight, what order of magnitude prefix can you use? Well, the answer that you probably know is 1 kilogram. Use kilo. And the kilogram, as we saw above, is a basic SI unit, and it's the only one which actually uses an order of magnitude. Moving on, what about this many bytes of information? That's actually a billion with 9 zeros. A billion bytes of information. Which of the orders should we be using for this? Well, it is the gigabyte. That's right, a billion bytes of information is a gigabyte. And finally, what about this one? So now we are looking at 0.000001 meters of distance. So this one might be a little bit tougher, but we are going in the other direction, and this is 1 micrometer. 1 micrometer, and it has a strange symbol there. That is the Greek letter mu, but we use it just like a normal letter when we are writing units. Here is a full list of orders as shown on Wikipedia, and to be honest, we might need even bigger and smaller numbers in the future, but there is another way that scientists can use to write these numbers, and that's what we're going to look at in the next video on standard form or scientific notation. It will include a little bit more maths talk, and hopefully that will help you to understand exactly how these orders are working, because it's a key part of science. Thank you very much for watching this video though. I hope you found it useful. If you have, then please like it and maybe share it with a friend. You can ask any questions you like down in the comments below, and why not subscribe to MYEP so that you can keep up with all the new videos. Thanks for watching, and bye for now.